Okay, number 5 from our spring 2012 final exam. We're given some information about the path of a flight. When you first see this, you might think of relative motion, but we're not given anything about airspeed or wind speed. So this is simply just a vector addition problem dealing with displacements. So let's draw it out here. Alright, let's draw a north, east, south, and west. If we read through here, we're told that the x-axis is east and y-axis is north. So let's make a note of that. And then draw out some vectors here. So the first one, 40 miles, 30 degrees west of north. So let's go 1, 2, 3, 4. 40 miles, here's my 30 degrees. And we have this vector right here. Okay, then we fly 50 I minus 20 j miles. So let's go 1, 2, 3, 4, 5 to the right, and 1, 2 down. So this vector is actually from there to about there. Okay, 50 and 20. And the question is, how far do we have to fly to get back to where we started? So we want this vector, I'm going to label it C. We want its magnitude and direction. Okay. So if I label my black vector A, my blue vector B, then really what we're saying is we want A plus B plus C added up to be 0. So we can do vector addition with trigonometry or with components. Components always work, and many times they're easier to do, especially if part of your information is already in component form. Just a little bit easier than messing with a bunch of interior angles and so forth. So let's look at the x direction for this one. If this is true, then the x components will also have to be 0. The x component of A here, if I were to sketch out a triangle right here, is going to be negative, and the y component is going to be upward. Okay, and this is going to be 40. Okay, my 30 degrees is also right here, so it's going to be 40 sine 30. And my y component is going to be 40 cosine 30, and this one's going to be negative. Alright, so for the x, minus 40 sine 30 plus 50 plus c sub x, the x component here. If I draw it in red, I know it's going to be downward for y, and to the left for x, c sub x and c sub y. Okay, solving that, go ahead and do it here. Looks like it's going to be 40 sine 30 minus 50, or minus 30, and that would be units of miles. Okay, same thing for y. We have a positive 40 cosine 30. Okay, this y was a minus 20. And then plus, I'll write it as plus c sub y, it'll come out to be negative, and that's going to be equal to 0. Solving for that is going to be 20 minus 40 cosine 30, minus 14.64 miles. Okay. So components are at a right angle, so the magnitude of C is the square root of 30 squared plus 14.64 squared. Dropped off my negative signs because I am squaring them. 33.4 miles is the magnitude. Okay, we also need to know the angle. So the angle is always given from the tail of the vector. So really what we're doing is trying to find that angle or this angle. This angle right here, this angle theta, is the same as this angle. Alright, so from that I can see that I can calculate theta as the inverse tangent of opposite, which was c sub y, over c sub x. Okay, which is inverse tangent of 14. I'm just working with an angle now, so I'm using the absolute values again. So theta is going to be inverse tangent 6.4 divided by 30, 26 degrees. Okay. That theta is off of the west direction in the south direction, so south of west. Okay, so 26 degrees south of west. It would also be okay to write the complement of that angle, the 90 minus 26, 64 degrees. That direction would be west of south. Usually you go for the smaller angle and write it that way.